All right, let's get started. The problem I'm going to be working on today is question 3 from homework 9. This question is asking us to find the capacitance of this capacitor. To start, we are given various powers, such as the power being absorbed by the load impedance and the power being delivered by the voltage source. So our first step will be to write it down. We see that the power absorbed by the load impedance, the active power absorbed, which is represented by the P, is 3,500. And the reactive power, which is represented by the Q, is 4,500 VAR. So that is all the power being absorbed in the load side of the circuit. And then we're going to move towards the line, right in the middle. To start, we see that it has the resistor and the capacitor, and they both are going to have power being either absorbed or delivered. The equation for the resistor, for the power being absorbed by the resistor, is the magnitude of current, RMS squared times R, which in this case is 12. And then we have for the capacitor, we have since it is a capacitor, it's going to be reactive power, so it's represented by the Q. It is power absorbed by the capacitor is represented by the magnitude of current squared times X. And since this is a capacitor, X is equal to 1 divided by WC. WC is just our radians per second, and C is just our capacitance. All right, let's move towards the source. All right, for the source, we are given that the power delivered is 9,800 watts, and that's for active power. We aren't given for reactive power, so we're just going to leave it blank for now. To start solving for X and eventually get to our capacitance of a capacitor, we must first find the current flowing through the circuit, and then find the power absorbed. The first thing we are able to find is the current flowing through it. We were able to find that because we have all the P's, all the active power already identified in our circuit, like for the load, for the line, and for the source. And we're able to use, which our second step, we're able to use that power delivered is equal to the total power absorbed, which in this circuit will be the power delivered by the source is equal to the power absorbed by the load impedance plus the power absorbed by the resistor. And we're going to plug in the expressions and the values that we have. That is 9,800 is equal to 3,500 plus the magnitude of the current squared times 12. From here, we're just going to solve for the current. That'd be simple. We just subtract both sides by 3,500 and then divide by 12. We're going to get that the magnitude of the current squared is equal to 525. From that, we can just square root both sides. And boom, we're able to find that the current flowing through the circuit, the current RMS for this circuit, the magnitude of it is 2291 amps. So we found the first part. Now, if we want to find the current absorbed by it, we are able to use, we're going to move on to the next step. And we're able to use the formula that the magnitude of the apparent power is equal to the magnitude of voltage times magnitude of current. We already solved for the magnitude of current, and this circuit was nice enough to give us the voltage. Voltage is going to have an angle. It's just going to use that as the magnitude. So it's 9,500. Perfect. So if we just multiply both of these, we get that the magnitude of the apparent power for the voltage source is 2176 72.34 VA. Perfect. now that we have the magnitude of the apparent power, or just S, let me see, we are able to start solving for the reactive power delivered, and from there we can start working towards the figure out the reactive power absorbed by the capacitor. But as you notice, it's asking for delta. We are looking for this, but we don't have delta. But luckily, there is another equation that we can use, and values that we already have, which is power delivered. I mean, the active power delivered is the magnitude S times cosine delta. We already have both of these, so we just solve for delta. For that, we just divide both sides by magnitude S, and we get cosine delta is equal to 0.045. From there, we just get the inverse cosine for both sides, and we get that delta is equal to 87.42 degrees. Perfect. From here, we're able to just plug this in right into there, and then find the magnitude as we already have, and we're able to find for the reactive power delivered to this circuit by the voltage source, and that is 217451.63 VAR. All right, now we're able to move on to the next step, which will be to find the reactive power absorbed by the capacitor. So we use the already known equation that power delivered is equal to power delivered is equal to total power absorbed, and we get that the reactive power delivered is equal to the power absorbed by the load impedance minus, because it is a capacitor, so it's going to be minus the power absorbed by the capacitor. Something to note is we already have this value and this value, and we're just going to subtract it. But we see from right here that that's 4,500, and the final value is way bigger than that. So obviously there's an error in there. The reason, so obviously there's an error there. But if it's negative, it's gonna make sense because if the power delivered is greater than the power absorbed, we're just gonna subtract from the power absorbed. The value we get is not gonna make sense. But if we make it negative, then it's gonna fit into our equation. And the reason for why we make it negative is having to do right here. We get that delta is equal to 87.42 degrees. And then we just push that into right here. But the problem was that 87.42 degrees was actually negative, which will make this negative. The reason why it didn't pop up is just because for cosine doesn't care about sign convention. It could be positive or negative. It's still going to give you the same degrees. So it's important to look at your equation and see if it makes sense. We noticed that it doesn't make sense, so it's a good thing we caught that. Now we're able to proceed that the power delivered is actually negative 217451.63 VAR. Perfect. Now from there we can just proceed. We plug in the values I already have. We have the equation. This is the current RMS. From here we just solve for x. We get that x is 422.76, and then from here we're on our last steps. Which is step 5. That is just we know that x is equal to, from here we know that x is equal to 1 over WC, and from there we just solve for C. We are given frequency. From there we just multiply frequency by 2 pi. That's how we get radians per second. And then from here just we have that equation, and something you can just do is just multiply a c to the side and just divide both sides by 422.76, and we get that equation. Once you plug in all the values into our calculator, we get that c is 3.76 microfarads. Perfect. We're right.